about how browsers work. I always had the passion to understand the underlying principles of how things actually work, and by understanding those underlying principles, it helped me to develop things on top of it. So recently, I've decided that I don't really know how browsers work, and I wanted to learn more about it. So beforehand, I have to have a very big disclaimer. I'm not a browser engineer. My work is not developing browsers, but I still wanted to explore what browsers are all about and how they do their magic. This is just me being humble that there might be questions from the audience that I might not be able to answer. So let's start with the browser components. A browser consists of user interface layer, a browser engine, a rendering engine, networking, JavaScript interpreter, UI backend, and data persistence. User interface I would define as everything which you see, but you can't manipulate. So the address bar, the settings of your browsers, you can't really manipulate that, and that is a user interface. User interface is working together with the UI backend, and this UI backend is designed to develop basic widgets. Browser engine works as a mediator between user interface and the rendering engine. So if you were to press refresh on your browser, then the browser engine would take that command and execute it for you and refresh the web page. So rendering engine is the part which parses the HTML, CSS, and JavaScript, and based on the results of that which is being parsed, it's going to display the page. So networking, it's when you have an HTTPS or an HTTPS request, networking layer is going to make sure that the resources are loaded. JavaScript interpreter is going to interpret the JavaScript, and the data persistence. So here we are talking about cookies, local storage, IndexedDB, file system, etc. So as you can see, browser consists of lots of layers, and it would be very challenging to cover every single one of them in one talk. And since this is a front-end conference, I'm going to focus on the rendering engine. So first of all, let's take a look at the basic rendering engine flow. So what happens? First time when you open the website and the rendering engine is being started, first it is being parsed. Then after the parsing step, the tree is rendered. Then after that tree is rendered, then something called layout is executed. And depending on the browser, it may be called layout or reflow. And after that step comes the final step called paint, which just fills out the objects with colors. So right now I'm going to focus on each of those steps in detail, starting first with the parsing. If you were to develop a parser, you would soon see that there are two types of parsers. There could be a conventional parser and unconventional parser. For conventional parsers, you can use them to parse CSS and JavaScript, but for the unconventional parsers, you are going to need to use for HTML. I'm going to explain first the conventional parsers, and then I'm going to explain why HTML requires an unconventional parser and how it uses it. So this is parsing 101. If you were to go to Wikipedia, you would soon find that Parsing can be defined as translating a document into a structure that code can use. So let's now focus what that means. You see this picture over here. It consists of a mathematical equation, and we need to somehow parse this equation to a certain tree, which our code can later on use. So the parsing actually consists of parsing consists of grammar, and grammar entails vocabulary and syntax rules. Vocabulary is like, in our language we have A, B, C, D, or more specifically we have words. And here you have, instead of the words, you have numbers for this particular case, and you have these mathematical symbols like plus and the multiplication sign. So those numbers and those symbols are going to be our vocabulary. Syntax rules is basically how those integers, so basically how vocabulary interacts. So you know that the multiplication sign can only be between two integers, floats, or whatever, but in this specific case, let's focus on it being just integers. And plus can be before an integer or after an integer, or between two integers. And once we take a look at how that is being parsed, we can see that that plus is at the bottom, at the top. At the left side of the tree, you can see 1. On the right side, you see multiplication sign together with the numbers 2 and 3. And you can feed this to a certain code, which is going to take advantage of it and generate some kind of result. So let's go a little bit deeper into it. So parsing contains lexical analysis and syntax analysis. Lexical analysis is usually being also called lexers or tokenizers. It is that part of parser is basically creating the tokens. And tokens are the smallest elements that a parser can use. If the second thing is parsers. Parsers apply the syntax rules. Here we can see a diagram where we have a lexer and a parser. Parser is going to constantly request tokens from the lexer, and lexer is going to reply with sending the tokens. Parser is obviously going to try to use the token based on the syntax rules, but if that is not possible, it is going to store the token, and at later time, it's going to see if that token can be matched to something. So you could go the route of developing your own parsers, and that might be a good thing to do, but usually there are already available parsers like Flex, Lex, Yak, and Bison. And for these parsers, you have to just feed it with your grammar, and they are going to work using it. And the funny thing is, even WebKit is using 2 of these parsers. WebKit is using a Flex for lexer, and Bison as a parser. So right now, let's move to the unconventional parsers. I said that for the conventional parsers, you could use them for parsing CSS and JavaScript, but for HTML that doesn't work. And it doesn't work because HTML is not context-free grammar. To put it in layman terms, that means that as you're parsing the code, the HTML, the browser is going to try to immediately recover from any errors that might occur on the way. And here we can see 2 images. One image is displaying a perfectly valid HTML5 document, and the other one is not displaying a valid HTML5 document. You can see that on the right picture, the closing tags for paragraph and div tag is missing. But even because those two tags are missing, those two closing tags are missing, the browser is still going to render it correctly. How it's going to do that exactly? It is automatically going to add a closing tag for the paragraph and the closing tag for the div, and then you're going to get your page rendered. Because of that, you can't use regular conventional parsers. So there still, even though you're not using conventional parsers, there still have to be some kind of rules, and those rules are defined by the HTML document type definition, defined by the World Wide Web Consortium. This is one more example where you might go, so this example is obviously going to work, but if you try to have maximum number of amount of tags, at some point browser is just going to ignore them. There is one website which has approximately 1,500 tags going one after each other, which are all of the same kind. And even though that website has so many tags, it is displaying perfectly normally. So how do you parse the HTML document is fairly simple. You have your valid HTML5 document, and if you remember the principles from the conventional parsers, the same thing can be applied here. So here, the only difference would be that you are first going to try to look for the opening tag, and then you are going to try to match that tag with the closing tag. Then that's how you are going to slowly and incrementally build your tree, which you later can use to render things. So right now, let's move on to the next step, which is called render tree. Render tree is generated while the DOM tree is constructed. So on one side, you have DOM tree, which is being constructed, and at the same time, rendering of the render tree is being constructed. So render tree is basically visual elements, and in which order they need to be displayed. Again, based on the browser, you might have the terminology might be different. For example, it might be called the renderer, or it might be called render objects. Those are the small elements which this tree consists of. And one important thing to note is that those render objects, those smallest elements, are basically rectangles. Now, when you go and try to render it, and you try to investigate code, how it works, at some point you're going to stumble upon a switch case, which based on whether it is render none, based on the definition of the DOM element, it's going to render it as render none, render inline, render block, inline block, or list item. Now let's move on to the layout. So layout, or also called reflow in Mozilla browsers, calculates position and the size. So most of the times it is possible to calculate every single thing in one pass, but in the off chance that it is not possible, then it is going to go multiple times and try to calculate the size and the position of each and every element. It is a recursive process, and usually it begins at the root object, which is an HTML tag. Layout also has something called dirty bit system. This system makes sure that you don't have to run full layout on each browser interaction. So let's say you just modify two nodes, two DOM elements, way inside of the tree. There is no need to re-render the whole tree. You could just relay out those two and not worry about the rest. But it is so there is also this global and incremental layout. Global layout is when you're doing a resize of your browser, or you apply new font, then the whole layout is going to be executed through the whole page. And the incremental layout is basically using the dirty bit system to render some of the things, but not everything. So here I have a video about Gecko reflow. So as you can notice, in Mozilla, it's called reflow. This is just showing you how the layout process happens. If you see those rectangles, and if you paid attention, those render objects are these rectangles, and the layout process just calculates where each rectangle needs to be positioned. This was done by some Japanese hackers or something like that. And afterwards, they shared this, and it was very beneficial in understanding how browsers actually work. The final step is painting. So you saw those rectangles, you just now need to fill them with the color. And that's what the paint layer is doing. Paint is going through the render tree and basically executing recursively the paint method, which displays things on the page. Again, like with the layout, there is a global and incremental painting. Global, if there is global painting needed, then the whole page is going to be repainted, and incremental painting is using the same dirty bit system, so only some crucial parts are being repainted while others are being as it is. The painting order is usually background color, then background image, then border, then children, and finally outline. If you ever had a div which had background color and then background image, and let's say the background image was particularly big, you might have seen that the first thing is going to be the background color, and afterwards you're going to get your image. Now, I know that this talk was very basic, but I wanted to do it basic and understand the principles behind of the web browsers. And I would like to impart a few words of wisdom, which is I hear and I forget, I see and I remember, I do and I understand. It was said by Confucius, and it basically means you really understand something when you try to build something. So I would try to invite you, if you have the time, the resolve, and the interest, to develop your own browser rendering engine, because only then you are going to truly understand. Right now you saw this presentation, and you might remember it, but until you get your hands dirty, you're not going to understand the peculiar intricacies of the browser. If you were to go that step and you want to build your own browser rendering engine, I found two very interesting links that I decided to share. The first one is how browsers work. It is basically what this talk is about. There you have a woman who decided to do the very same thing as I did, but way before me. And she took the source code of Chrome and tried to see how Chrome works. This presentation was based on her work, and later on I stumbled upon about let's build a browser engine. A person from Mozilla team decided that just working on a browser as a part of the big unit is not enough, and he decided through the small 7-part series to develop a toy rendering engine, particularly because he wanted to see how it is to develop it on your own. He managed to, in approximately 1,000 lines of code, to develop a rendering engine which is able to display basic stuff. Yeah, I mean, this is the end of the presentation. If you want to follow me on Twitter, my username is here, and that's it. Now, if any questions,